Hello, Chem 1B. This is Chapter 22, Lecture Video 3, and we're going to be talking about naming complex ions. Now, in the past, we've learned how to name things. This is going to blow all that out of the water. Naming complex ions is 1,000 times more difficult than naming an ionic compound or a molecular compound, so it's going to take some practice. There are rules, just like there are rules with naming any compound. And in complex ions, the first thing we need to worry about is whether the ligand is neutral or not. Now, if the ligand is neutral, then we name it normally. So whatever it is, we just name it that, right? For instance, like if we had carbon dioxide, then we would name it carbon dioxide. But if it's water, we have a special name for it, and that's aqua. Or NH3 is not ammonia, it's amine. And finally, if it's carbon monoxide, we don't call it carbon monoxide, we call it carbonyl. These three names are kind of the names we use for these ligands, and you should know them. I shouldn't have to tell you what they are. When we name anionic ligands, the name is the ion plus an ending. Now, how we determine the ending depends on what the anion's name ends in already, right? So if something ends in IDE, we change it to IDO, right? So for instance, if we have Cl minus, we know this is chloride. So chloride, when we name an ionic, when we have chloride ligands in our complex ion, is not chloride, it's chlorido. I love saying these ones. They just are a lot of fun to me. If something ends in ATE, we change it to ATO. So for instance, NO3 minus is nitrate, right? And nitrate becomes nitrato, right? And if something ends in ITO, like for instance, NO2 minus, nitrite, we change that to nitrito or ITO. So nitrito. So these are rules that you do need to memorize. All right, so let's move on to the next bit. So the way we name complex ions is we start with the ligands, always the ligands, not the metal center, even though the metal center is written first in the formula. We write out the ligand names first in alphabetical order before we name the metal ion in the complex ion. We use prefixes to indicate the number of ligands when there is more than one, and we use our just normal molecular compound prefixes, di, tri, tetra, penta, hexa, and these are the only ones we use. If there's only one ligand, then we just don't use a prefix. If the ligand's name already includes a prefix, this is something new. We have to use a different set of prefixes, not di, tri, tetra, penta, hexa, but instead bis, tris, tetrachus. We also put parentheses around the ligand name, and we'll do some examples of this in a second. Finally, once we've listed all of our ligands in alphabetical order with their prefixes, we then name the metal center in the complex ion. Now, if the complex ion overall is a cation, then we just write the name of the metal followed by the Roman numeral for the charge. And that's it, then we're done. However, if the overall complex has a negative charge, i.e. is an anion, then we have to change the ending of the metal ion's name to ATE. So for instance, in this scenario, chromium, if it was a negatively charged complex ion, would be chromate. And then probably like 3, right? So we just change the IUM to ATE if the overall complex has a negative charge. Lastly, we add the counter ion name. A lot of times our complex ion has a counter ion to balance its charge and make sure it's a neutral complex. We just name that part as a normal ionic compound would. So for instance, if I have this complex ion, blah, 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 and then I have Cl on the outside, then I'd name this part, the complex ion part, and then this bit would just be chloride. Because it's outside the brackets, it doesn't become chlorido, it's just chloride. So let's do some practice here. We need to name the following complex ions. So let's name this guy. All right, so to start, I know this is platinum, it's transition metal. I know this is NH3, ammonia, but remember we have a special name for it. It's amine in complex ion naming. And this is normally chloride, but here we call it chlorido because those are our rules. We changed that ending. Now we have some prefixes to add here, and we know our charge here is negative, so that changes our rules for naming the metal ions, the metal part of the name. But the first bit, alphabetical order. This guy starts in A, this guy starts with C, we're going to start with A. I have 2 amines, so this is going to be diamine. And then now I have 4 Cl's, so this would be tetrachlorido. And then finally I have my platinum, which I'm going to say is platinate. Because again, it's a negatively charged complex ion, so the ending of our metal becomes ATE. Now the last bit here is I need to figure out what the charge is on platinum in this compound. And I know this guy, the NH3, is neutral, but I have 4 Cl minuses, each one with a -1 charge. So that gives me a -4 from this part here. I need to figure out, hey, if this is -4, what the charge on platinum has to add to -2, meaning this must have been 2+. So I can then put in parentheses here, Roman numerals 2. And there is my name for this complex, right? Diamine tetrachlorido platinate 2. As a general statement, names for complex ions are pretty long. Okay, so let's do another one. Oh, sorry, I left this in here to mention this. An old set of rules is to use an O instead of IDO. This is the new updated naming system. They just recently changed it about 2 years ago. So if you see anything with with an O instead of IDO for IDE endings, that's why. It's because it's a recent name change. So let's look at this guy. This complex ion's ligand here is known as ethylene diamine. Actually, it's just one M in this one. Ethylene diamine. And you should know that guy's formula. If you ever see EN in the complex ions formula, that's an abbreviation for ethylene diamine, and you should know that as well. Again, we have amine here. And here's our counter ion in this case. So it's not chlorido, that's just chloride. We got manganese here. So let's start. We know this is our alphabetically first, and we have 2 of them. So I'm going to say diamine. And then here's where it gets a little bit more complicated because this guy's name has this prefix in it, di. So we can't use our normal prefixes for this ligand. We have 2 of them. That means this is going to be bis, parentheses, ethylene, diamine. And then we name the rest, right? So the next bit is, and you got to put the parentheses here when you use bis, tris, tetrachus. The next bit is manganese. and we got to put Roman numerals here. Now, both of these two ligands are neutral. So I know I have 4 Cl minuses attached to this complex ion. So that means that the manganese must be 4 plus. And then we just write chloride. So let me just erase my little notations here. Here we are. It is diamine bis ethylene diamine manganese 4 chloride. Like I said, these names can get kind of long. All right, so here we have another counterion situation. Here's our counterion. This means that this must have a -1 charge on it, right? Because sodium's +1 and there's 1 of it. Let's start with sodium because as with all ionic compounds, we always start with the cation. So we're going to start by just saying, hey, this is sodium, space. Now let's name the rest. This guy is oxalate, which will become oxalato. And this is aqua, the special name for water. So when I name these prefixes, I start with the A1, right? So this is going to be diaqua. And then oxalate is kind of a weird one because oxalate and oxalato, they're kind of like almost common names, but they're the ones that are almost always used. But you might see people say use bis tris tetrachus with oxalate because its IUPAC name actually does have a prefix in it. So I will accept either in like tests and whatever, but your online homework might only accept oxalate with bis. So do whichever one you feel like. Honestly, I don't really care. If you're using bis, you do have to put parentheses around oxalato. I'm just going to say this is dioxalato. And then we go, oh, hey, it's chromium. But chromium becomes chromate because this is a negatively charged complex ion. So it's chromate. And now we got to figure out the charge. The water is neutral. This guy is -2. Oxalate is -2 charge, but we have 2 of them, so that's -4. Whatever chromium's charge is has to add with -4 to give us -1. This tells me that the charge on chromium is 3 plus. So this is my name, sodium diaqua dioxalato chromate 3. Again, another way of saying this, and technically, honestly, the more accurate way would be diaqua bis oxalato chromate 3. And then, you know, same with the sodium thing. So sodium diaqua bis oxalato chromate 3 is actually technically more correct. I will accept either one of these because it's not very clear that oxalate has a prefix in its name. As we usually use it, it doesn't. But the IUPAC name for oxalate does have one. It's just not the name you guys know it by. So I don't really care which one of these you use. Do whichever one, you know, you're more comfortable with. Okay, so let me erase so you can actually see the... I think I did it without bis. So here, I'll leave the bis one here. All right, so let's go the other direction now. Oh, sorry, I got one more. So let's say we have this compound. In this scenario, since we have this Cl counterion, we know that the complex ion is positively charged. It has cobalt in it. We have water for aqua. We have NH3 for amine. And we have hydroxide, which becomes hydroxido. Hydroxido. That's a new one for me to say that way. And we got to put these in alphabetical order. So amine comes first because M is before Q in the alphabet. So we got one amine, so we just write amine. And then we have 4 aquas, so tetra aqua. And now we have hydroxido. And then we write cobalt, so cobalt. And we got to figure out what its charge is, right? Both the water and the ammonia are neutral, but the hydroxide is a -1 charge. We have 2 Cl's here attached to it, which means the overall charge has to be +2. So this is going to be 3+. And then the last bit here is just chloride to add on the end as the counterion. And that is our name for this complex ion. Right, so amine tetra aqua. Again, this O instead of IDO is an older naming notation that hasn't fully been eradicated from a lot of material. So this is technically the most correct as of up-to-date naming rules. This is the old naming rule. You might see either be used in a lot of different materials still. So that's why I'm continuing to have both in my slides. We got to be able to go the other way too. So if we have the name, we should be able to write a formula. So let's look at this one. We have potassium hexacyanoferrate 3. Some metal ions have special names when they're anions, like iron, silver, lead. Instead of it being ironate, it's ferrate, going back to the Latin name of iron. Or lead is plumbate, silver is argentate, and you do need to know those special names. There are lists in your textbook of them. So make sure you go back over that. We know potassium is plus, K+, and so let's write out the rest of this. We have iron, and we have our brackets to start our complex ion formula. We always start with the metal in the formula, and we have hexacyano. Again, this technically should be cyanido if we're following old rules, but you should, or new rules. This is the older method. You won't see it probably as frequently, but I know sapling does still have some that use an O instead of IDO. That's why I have it still in these slides. So cyanide is what this was prior though, regardless, right? So we have CN is cyanide. We have 6 of them. So we're going to write FeCN6 in parentheses. Now we got to figure out what the charge is. If I have 6 cyanides, each one at -1, and an iron 3+, then this is going to be 3-. My formula is going to be K3 brackets Fe parentheses Cn6 close my brackets. And this is my compounds formula. Let's do one more. Here we have 2 separate complex ions. We have tetra aqua platinum 2. So I'm going to start by doing PT. Let me move over here so that we can. Platinum is PT, and we know it's 2+. And there are 4 waters. So I'm just going to write H2O parentheses 4, close the brackets. This is going to be overall 2+ because, you know, water is neutral. So if my charge on platinum is 2+, then my charge on the complex is 2+. Then we have our next bracket. Platinate is still platinum, so we still have a different complex but with platinum. And we have Cl6 because hexachloro or hexachlorido would be that. Now it's 4+, so this is 2- overall because 6 Cl's, that's a -6, plus 4+ gives me -2. Bringing these together, they come together on a 1-to-1 scale, so we get, you know, this overall compound formula. All right, so if you guys have any questions at all, please feel free to email me. Naming these compounds takes practice. More practice, the better. In addition, you know, as always, you can come to discussion sessions for help.